Hello everyone, welcome to Curious Minds. My name is Akshay sir, and now we'll be discussing about this question. This question was asked in JEE Mains, which was conducted in 4th April 2024 in the shift 1. So let's read the question. So they are saying that there is an infinitely long positively charged straight thread, which has linear charge density as lambda. Okay, lambda. Now there is an electron that is revolving around that thread in circular orbit, okay, circular path, basically having axis along the length of the wire. So if this is the wire, it is doing this. Okay, so what they are asking us, that we have to pick among these the graph that correctly represents the variation of its kinetic energy as a function of the radius. Okay, so how that kinetic energy changes as a function of radius, that is what we have to figure out. Okay, fine, let's do it. So first write down the electric field that system creates. Okay, so we know that electric field is going to be your 2k lambda by r, right? K being that constant of the that we use in the Coulomb's law. Okay, fine. So this is how electric field behaves as a function of r. Okay. Now, so if this is the electric field, we know that the force produced by the electric field is nothing but Q into E. So, and which can be written as, for this electron, that Q is going to become E, and then it will be 2k lambda by r. Okay. So our force is this. Now this is the force responsible for that circular motion of that electron, right? So this will be the centripetal force, which is nothing but mv square by r. Okay, we can simplify that. So r get cancelled, right? And then hence this implies your v square is e 2k by lambda over m. Okay, yes. Okay, fine. So now, but what is the thing that we are interested in calculating? We want to calculate the kinetic energy, right? Which is nothing but half mv square. Okay, which is nothing but half m into, now this is what the expression for v square is, right? I'll be putting it here. So what do I get? It will be e into 2k lambda by m. Okay, now things get a bit simplified. This m gets cancelled, this 2 gets cancelled. So what we get is E into k lambda, right? So the kinetic energy is basically independent of r. There is no r there, right? So yeah, so definitely the answer is going to be this one, second one, because it basically shows that kinetic energy is independent of r, right? So this is our answer. Okay, yes, thank you.